Welcome back to Laugh and Code, the Elm Programming Show, where today we're diving into the world of lists and loops in Elm. Imagine lists as the conga lines of the programming world. Once you're in for a loop of fun. But fear not, we have no traditional loops here, just pure functional bliss. So let's start our conga. In Elm's realm, every tale starts with an empty list, a canvas of possibilities. Soon, the singleton steps forth, a lone hero, marking the beginning of assembly. Enter cons, where elements gallantly cut to the front, one by one adding to the saga, swiftly and with purpose. Yet append steps in last, a cumbersome list of allies, disrupting the pace by joining from the rear. Thus unfolds the epic of lists, from silent emptiness to a lively ensemble, orchestrated by the swift cons and the slow append. Here's the first practice question. Fill this list with your favorite mythical creatures. Then use the cons operator or : to add a dragon to the front of your list. Here, this is the first practice question. Define this list of your favorite mythical creatures. It's a list of strings. Then, add dragon to the start of that list using the cons or : operator. This source code will be available as the first pinned comment below. Then you can copy that source code to the online editor at elm-lang.org/try. Pause the video now and give it a try. For mythical creatures, I'll add unicorn, werewolf, and sphinx. Then to add the dragon, and let's see if I got the syntax right by hitting rebuild in the bottom middle. Looks good. When completing this problem, you wouldn't need to rewrite out this list here, because we can just use this variable name, and dragon would not be a list of its own, because cons works on one item on the left, or an element, and a list of items on the right. Also, these types need to match. The list of this one dragon needs to be the same as any item in this list. In Elm, every item in a list needs to have the same type, but if you wanted a heterogeneous list, then you would use a custom type that has multiple different variants. Then each item can have a different one of those variants within it. Immutable lists in Elm are like those infomercial products that never change. Imagine trying to convince your immutable list to try something new. It's like saying, "Why don't we add skydiving to our weekend plans?" And your list replies with a polite but firm, "No thanks, I'll stick to being exactly the same." They're the ultimate creatures of habit, making sure that every time you ask for a change, they kindly hand you a brand new list, leaving the original unchanged. Because who doesn't love having duplicates of everything? Returning to our problem, if we replace this updated creatures with mythical creatures, we can see that here we haven't changed mythical creatures. It's still unicorn, werewolf, sphinx, and we have this additional list. Earlier, I said that the cons operator, or : was swift. It's also memory efficient. After we've made these two lists, this list is shared in both of these lists. with this added node simply linking to this other immutable list. So that's the big advantage of using these immutable lists. Imagine you're at a buffet, but when you're almost done your list of food items, a mystery dish is added. Obnoxious, right? In Elm, adding items to the front of a list performs much faster than adding items to the end. In this practice problem, you'll create a list of dishes you've taken from the buffet, and then add the mystery dish to the end. What does your feast look like now? Copy the source code from the pinned comment below. Fill in the list of food items you've taken from the buffet. It's a list of strings. And here, concatenate the buffet dishes with a mystery dish using the concatenate operator, or ++. Remember, the ++ operator uses lists on both the left and the right. Give it a try. For the buffet dishes, I'll have an egg, bacon, and bread and butter. Then to concatenate it, first I'll add this buffet dishes, ++, and then the mystery dish needs to be a list of 1. So we can't just concatenate a single item, we have to concatenate a list. If we would like to concatenate one item, it has to be a list of 1. This is also identical to list.singleton. Let's rebuild this and see if it works. And here it works. We can see that the mystery dish is on the right, or the end. And remember, every item in the list needs to have the same type. So if you made the mistake of putting the buffet dishes also in a list, then this would be a list of strings. Let's see what compiler error we would get. See, this is a list of strings, whereas the right side is just a list of strings. And then to get that to work again, I'll just remove these square brackets, and now it works. Have you ever noticed that in Elm, cutting to the front of the line is actually encouraged? It's like being in a crowded coffee shop, but instead of waiting your turn, you just slip the barista a note saying, "I'm running Elm." Because in Elm, it's all about first in, first out. The sooner you jump in, the sooner you're out. It's the one place where cutting in line gets you served faster, not thrown out. In Elm, the cons operator, or : performs faster than the concatenation operator, or ++. In the previous video, we talked about higher order functions. Well, higher order functions really shine when it comes to lists. This is why we don't use for loops in Elm. In this example code, we use the list.filter function to filter out the odd numbers in this list. Then we use the foldl function to add up any of the remaining integers. List.filter filters items out of a list based on the first function it's passed, and the second argument is the list that gets filtered. The result is a shorter list that here is being passed to foldl. Foldl turns a list into a single item, starting with this initial value and applying this function to each item in this list combined with the latest value. We determine if an integer is odd or even using this modby function. The modby function can be found at the URL package.elm-lang.org, and then clicking on elm/core, then browse to the basics module, and scrolling down to modby, it's right here. And if you need more information about what modular arithmetic is, click on this page to see the Wikipedia explanation of modular arithmetic. In this practice problem, you'll add 1 to each item in this list of numbers before passing it to this sum of even numbers. To do this, we'll use list.map. List.map can be found in the core packages under the list module right here. It takes a function for the first argument. That's the one that does a mapping on each individual item. Then the second argument is a list of all the items. Each item in that list will be given to this first function. And then it'll result in a list that are the result of each of that function being applied to each item in the second argument list. As a bonus challenge to this practice problem, you can write an inline function, kind of like this, instead of using this add1 function. This source code here will be available as the first pinned comment below. Give it a try. All we have to do is use list.map space add1 and then the list that's being mapped, numbers. And let's see what the result is. The result is 12 because all of the odd numbers are 1, 3, and 5, and if we add 1 to each of those numbers, we'll have 2, 4, 6, the same numbers that were added before. If we add 7, then we'll get a new result. And for the bonus challenge, writing add1 as an inline function, it needs to be written in parentheses, \n, arrow, n+1. And there we have it. This is the list transformation song. Map, filter, fold, oh my. Transforming lists as we fly by. Mappings like a wizard spell. Changing data oh so well. Filtering, we choose with care. Only the chosen dare to share. Folding brings us to the end. Summing up, our final friend. In the world of Elm, even wizards sometimes get ahead of themselves, combining spells in a single all-powerful incantation. Our task now is to gently unravel their work, separating the mighty foldl from its companion filter. Let's refine our magical code, applying filter to select our cherished elements before we foldl them into a grand result, demonstrating the art of patience and precision in the craft of Elm wizardry. This practice problem is a lot like the last. It filters out one type of item from the list, and then it sums those up and returns the count into the identifier count fantasy. To complete this practice problem, look at the previous problem and try to make it suit this one as well, where we're using a filter and then a foldl, rather than just a foldl. The code will be in the pinned comment below. As a bonus challenge, try to not use foldl at all. Give it a try. First, let's not filter out the fantasy items. We'll just add all items. Like so. And let's rebuild to see if we get 3. There's 3 items here, so we should get 3 here instead of the 2. So I'll click rebuild. Then this list of books still needs to be filtered. So let's put the filtering code here. It'll be list.filter, then the function, and then the list of books. Let's write a function to do this filtering rather than an inline function. So it'll be filter fantasy. Each book item is called a tuple. We haven't covered tuples yet, but it's pretty simple. They're just within these parentheses. So it'll be the title and then the genre. Then we have to filter out, it needs to be true if the genre equals fantasy. So we can say genre equals fantasy. Then give this filter fantasy function to the filter function. Like so. Now let's see if it works. Excellent, so we got 2 as we expected. We see 2 fantasy genre books here, and this summed up to 2, so it looks like it works. Now, for the added challenge, we don't actually need this foldl function because this foldl function is the same as a list.length function. So there's just a function that does that exact same thing. So we'll rebuild it again and it still works. As we close our conga line of lists and loops, loops and lists, remember, in Elm, every list tells a story and every function plays a part in the dance. Stay tuned for our next episode where we dive into the magical world of Elm and the Web, a love story. It's going to be like discovering a new dance move that changes everything. Don't forget to subscribe, share, comment, and like so you don't miss out on the coding adventures. Until then, keep coding, keep laughing, and never stop learning.